They were really, really interesting. And the other thing that we looked at with this is even more is like, if you can predict these diseases, what about the biomarkers to them as well? Like your CRP, your cholesterol, these things. Can we impute like different levels of that from epigenetics? And what I can talk about is just on Sunday, there was a study that came out that showed that you have these proxies for these biomarkers. And in fact, in this study, what they showed is that some of those imputed or predicted biomarkers, like for CRP, perform better than the actual CRP, which makes sense because if you think about CRP, it bounces around all the time. Your glucose, I don't care what your spot glucose is because it bounces around. I don't know your A1C, it's an average over time. So it looks like these proxies are an average over time that maybe better measure the biologic effect. So again, I can't talk about our results yet, but in the study that just came out, they found that those were actually better than the other biomarkers. So we looked at about 4,000 proteins, metabolites, and other things and said, can we predict these with epigenetics, with this big data and AI? And I was very excited about the results of that as well. And when we do get the preprint out, I'll send it to you so you can see. But that's what I'm most excited about, to potentially have a test, just a few drops of blood, that could diagnose all of these diseases and give you all these biomarkers. Because like if we diagnose you've got chronic kidney disease on this, well, what's it from? Is it glomerulonephritis? Is it like an infectious thing? Is it a genetic thing? There's different tests for that. Well, if we can also predict all the biomarkers that you would use to test that, then we get even more granularity. So epigenetics and DNA methylation is the future of testing.